So Matt asked me to talk about the origins of RTMP, the untold story, shrouded in mystery, and a little bit about how do I think it came to be a de facto standard. And so why can I speak to that, aside from being involved in the beginning and helping create this thing? Early in my career, my first startup was called the Company of Science and Art, and we did digital video off CD-ROM. Then we heard about QuickTime and quickly switched and developed After Effects. Later, I joined Macromedia to create Shockwave, which was then a code name, and made one of the first Netscape plugins. And all of that, I've had a lot of things that I worked on that you've never heard of, some of those things you've never heard of, and I've also worked on things that somehow last for decades. So I think I have a little bit to share about why I think some things last and some things don't. So I'm going to go back in time to the early days of the web, which, like by here in 2000, we didn't think it was so much early days, They were like, this is like around the time where we were coming up with the ideas for RTMP. And like by now, there are 248 million people on the web. Holy cow. It's 4% of the population of the world, and like, who knew it would get that big? So highlighted on this line, if you've got good eyesight, so you can see IE55. Who built a website in IE55 or earlier? Ooh, nice. You know what I mean. So IE55, for the new folks here, was the first IE browser to support CSS. And they didn't implement the rendering very well. So we were very unhappy until everybody could use IE6. But at that time, so like nowadays, we all like to hate on Flash. Right? Like, it's just not cool anymore. But in that era, Flash was like 200K of cross-browser goodness. Like, it worked, and that was awesome. And everybody had it. 99.8% of the people on the web had it. That was more people than had any single browser. So this was the world in which we created RTMP. So a little thing about code size. So Troy Evans, who was a PM for Flash at the time, did a little test. He took a picture from his vacation, and he bundled it with the Flash install. So adding 50K to the player, it's fine. Didn't change downloads. 100K, also totally fine. 200K, whoops, let's not do that. So we had to add two-way audio and video in less than 100K, otherwise we're totally going to fail. So Jonathan Gay, the engineer who wrote most of the original code for the Flash player back in, mid-90s, went off for like a year and thought about things and came up with a prototype for what he thought was this next generation of thing that he called tin can, as in two tin cans in a string. So Slavik Lozbin, who was originally on the director team, joined the Flash player team, came over to John's house to see this demo. And he tells this story about how John had a camera pointed out his front door. He had Flash running on his machine, and it was showing JPEGs, right, out from the front door, holy cow. And it had chat, right, in a little server. And John said, "I'm reinventing the phone." And Slavik was like, "I'm in. Let's do it." So at the time, I had forgotten that he said that, and because I kind of totally discounted it, because from my perspective, we were going back to the origins of the internet, because the internet was made as a communications medium, and then this web thing kind of broke it by just being placards and publishing, which is kind of what the web was then. So the original team was, whoever was CTO at the time said, "John, go pick any 5 engineers at the company." So the 6 of us got together. John was a VP by then. It was awesome to have a VP who still wrote code. And we came up with 10 stories of what this technology was supposed to do. And so I'll share 4 of them. The front door cam, right? So now it's ubiquitous in the smart home. They call it a a connected doorbell. The live classroom, of course, right? So this was not so of course back then, but the idea is that it had to mix up multimedia and real-time communications with recorded communications. And then, now it's sort of ubiquitous that you have these like little chat customer service things. That was like more novel then, and we wanted to support even if you just wanted to do basic text communications. And then NASCAR Drive was released in 2016, and this was our race car story. And so we had this story about how you'd be switching cameras interactively, and that was novel then because fast switching video from the browser wasn't a thing. The only controls you had for video in the browser was seek, and the streaming market was very saturated at the time. Those of you who were around then might remember, there was QuickTime Player. QuickTime had a browser plugin and a server, Windows Media, and Real Networks was the sort of big winner there. And so we didn't think that one-way streaming was really going to do anything, and we weren't going to be able to be competitive in that space, oddly. But this interactivity of mashing up streams, we're like, okay, that's where we can win. So what did the protocol need to do? So streaming, right? We had to be able to prioritize audio over video because in human communications, that really makes a difference. Low latency, important for having a conversation as well as the kind of interactive switching I talked about. Two-way, bidirectional streaming of audio, video, and data where we wanted to send enough information that the client and the server could mux and demux. And then we had three kinds of data that I'll talk about in a bit, and of course privacy was a big concern, which was mostly relegated to the client and that wonderful pop-up. And but later we ended up putting some things into the protocol to address secure transport and whatnot. So I want to take actually a few anecdotes about the protocol. So this was the message stream. Who recognizes this format? Few people have dived into RTMP, yay. So the key innovation here is really that there's 5 types of messages that you can kind of stream in a time-based stream, right? So there's audio and video, of course. There's a time-based data stream, the shared object, which allowed synchronization across clients or client to server, and a request-response command. And so you'll notice that the timestamp is 3 bytes, and I don't know, we didn't really think about it, or maybe we thought about it and then revisited the notion, and it was a week or so before the Flash Player 6 final release, and Brad was reviewing the protocol, Brad Edelman, and he was like, oh, whoa, that's 4.5 hours. I think people will want to have performances that are longer than that. So we added another byte, in a weird order, because we wanted to be well, if you filled up these 3, we'll just add one. And Pritham complains that there were a lot of server bugs he had to isolate at the, because we shipped the server a few months later. Because of this, but this allowed for streams that were over 7 weeks. And they're nobody's going to have a performance over 7 weeks. Well, it turns out later they had to write into the specification that time could roll over because they made these appliances that would just stream all the time, and you just you all know this already. But that was not something that we considered would be a thing. But it's okay because this was good for, I don't know, 6 years. I think that's pretty good. So anyhow, this is falling apart. The other little thing I want to highlight about the protocol is the chunk stream, right? So I've heard that people think this is a little wacky, but the key thing is what made this player win, in my mind, this protocol win, was the fact that it worked well on little tiny devices relative to this day and age, even relative to then. We had to work on older Macs and Windows machines, right? As well as being nifty in the new ones, and people still ran 4.4 modems, right? People We wanted to support all the people on the internet. And so most of the, so we wanted to have a long number of streams because maybe you'd have lots and lots of streams, but most of the time you only had a few for most applications. So we had, this is just an example of a piece of the chunk stream, but your basic chunk header, right, could be 1 byte, 2 bytes, or 3 bytes. And if you have less than 64 streams, if it's your first 64 streams, then you can have a 1 byte header, and that is significant over the life of the protocol. Saving these little bytes and bits here and there, adds up, where we actually thought through how can we make it so that the most traffic is under the size of the contents of a single TCP/IP packet. And this is what allowed us to do low latency, even in TCP/IP land. So, and so for those of you who haven't looked closely at this before, the reason that this second and third one are -64 is because, 2 to the 6 is 64. So we've already used up the first 64 and so forth. So the other thing, which is I'd like to think of as a Web 1.0 hack, unfortunately I think it's still true today, is how we dealt with the reality of the network, right? Sometimes when you're designing a protocol, although a lot of protocol designers don't seem to think about this, but we worried about what would actually work on the real live internet. And so we didn't do UDP at first because I'd just done the Shockwave multi-user server and knew that UDP was fine for gamers, but it just didn't work through most corporate firewalls. And, and then people would have to reconfigure their firewalls. And so that was a problem, and we just were maybe we'll do UDP later, but we'll do TCP now. And I was hoping that would be sufficient because I knew from some of my digital video streaming friends that, sometimes they had to do HTTP tunneling where you put TCP on top of HTTP, and I thought that was bizarre. Really? So it turns out, during Flash Player 6 beta, we did a test where we had oh, if you can't see video, go here and diagnose it. And we would try different things. So people would complain and they'd post to the support channels. And then we'd tell them to go to this little Flash app, which then we would modify the code to try different things. So it turned out that most problems went away by just doing a SSL socket over 443. So it would just go through because you weren't looking at, it was supposed to be encrypted. But some corporate firewalls actually looked at the traffic, even over secure channels because they had different stuff inside and outside. So we had to get through all of the firewalls. We had to actually devolve down to HTTP 1.0 in the worst case. And you'd think that this would be ridiculous and nothing would work, but it actually surprisingly, it worked much better than you would expect. But the key thing is, there were, all the big banks and some of the big older tech companies had these firewalls where it was just impossible. You could not ask them to reconfigure them, right? And so we designed this protocol, which ended up through this process of becoming this layered protocol that was on top of TCP, SSL, and HTTP. And then later, that kind of created a framework so that, they put it on top of UDP as well, for, with the whole peer-to-peer thing. So this is just sort of an example of there's a lot of FUD these days about UDP, and UDP is great, and we should do that. But at the end of the day, you also have to work with the reality of the world. So, so we launched in 2002. We had Kevin Lynch had this great idea for the launch. He was this guy, Doug Engelbart, is still alive. He built a platform very similar to this that actually had more features, as Doug told me, in 1968. And we should invite him to the launch. So I went down to his home in Atherton, and I set up Flash, a mic, and a camera on his 386. And, and he chided me that his system did screen sharing in 1968, and ours did not. And so I was yeah, you're more awesome than me, Doug. And so, so then Kevin does this, he shows what was called the mother of all demos. This is Bill Paxton, who was one of the first, later, one of the first engineers at Adobe. And he's in this video, and then everybody thinks that Kevin's just showing them like boring computer science history, and then Kevin brings Doug onto the screen, and they enact this portion of sort of computer science history, and then afterwards, I'm packing up the stuff, and Doug says, like, so if I wanted to do this for real and I didn't have you come to my house, like, how would I actually access this stuff? I was like, well, you have to buy a server. He's like, no, just but like the people accessing it. And I was like, well, it's in the Flash player, and we've only it's only been out for a few months, so it's only 30% of web browsers have it. And he was like, that's pretty good. So I felt a little vindicated. So so here we are. It's now 2002. And so the Flash player at this point, Flash player 6, right, which is the new version, we've actually managed to keep it under 100K of code-ish. And it's like, in June, it was like 30% of the web. By September, it was 50% of people on the web. By the end of the following year, 90% of people on the web had this new player that we'd built. And so it's this like, what we'd done is like, how that happened was, one, it was like a whole bunch of things that technically made it so it worked for all these people. The other thing was the content. So the sites came out. This is Phil Kerman's live cattle auction. So you could buy cattle for reals online. It was just incredible. Like Red Bull came out with this. Like it had like the race. You could actually have live video and the stats of the racers and where they were going around the track was like animated down here. It was pretty incredible. And then there was like these new entertainment experiences of a video wall. So this is Zed Uncut. So viewers would call in with their camera, and then he would show this video wall on TV. It was kind of meta. And then, so this is all this like interactivity that we expected, and then some stuff that we actually kind of, didn't really expect. Desperate Housewives, like one-way video streaming where we didn't think we were going to win. Like suddenly it started to happen, and then like Lost and full episodes streaming on TV, and then. The team wins an Emmy, like Adobe gets an award. I was gone by then, so I'm not in the picture, but yay, team. And so what this had, so this is like really the second part of the story. Because of the demand of streaming video, right? Like, so we sort of seeded this thing with the Flash player, and with like, I don't know, hundreds of thousands of developers who already know how to do this Flash stuff. But then, because of the demand of the one-way video streaming, they built up these relationships with all of the CDNs. So by like 2006, 2007, right, you can have, you don't have to install a server yourself, right? You can use a CDN, you can have it hosted on-prem, and then they came out with these new codecs that didn't fit in the Flash player. So Adobe came out with the Flash Media Live Encoder, which let you do high-quality live encoding. So now you've got all of these components, largely all running Adobe software. But then what happened after that, right? With all of these components, you start to have content companies like Justin TV, right? One person can start live casting using these tools from Adobe, right? Then we start to see open source implementations. And I should have had like Red 5, and like there's all of these other things up here. And so as this ecosystem develops, gradually every single thing made by Adobe is replaced by other things in the community. And you have these different niches of client-side technology and server-side technology hosted in on-prem, appliance, and whatever, all the different things. There are multiple players in each niche. And I think this is the story. This is why RTMP, where Flash is in its death throes over here, but it doesn't matter. That's not what it's about anymore. So here we are today. Is this relevant? Is this just like a little cute story in history? It is, but maybe it's more than that. So one of the things that I noticed as I was doing this like research and also helping this company Veriscope get off the ground and seeing if this RTMP stuff should go anywhere next, there's today 500 million IP cameras live on the internet. It's about the number of people on the internet when we released Flash, the Flash Player 6. So all of these features that we built for like human interactive stuff are still relevant for that stuff, but also outside of the browser with these little IoT devices and different types of clients. And so in the IoT space, there's like crazy amounts of growth. I actually didn't realize that refrigerators are the most common appliance that has video cameras today. In your smart home, your refrigerator typically has 3 cameras so that you can see what's in the fridge when you're not there. And it's actually going to save energy because we're not opening and closing the fridge all the time. It's like good for the earth. Who'd have thunk? So this like home appliance market with like smart TVs and smart video sensor things is supposed to grow almost 500% to 2020. Like this is like way bigger than the humans on the planet. So I don't know what the world's going to look like. Maybe it looks like this. I think it's pretty interesting. So that's the end of my story. If you have stories about RTMP past or present, if you have pain points of like things you want to be fixed, maybe I can influence that. And if you have ideas about the future, I'd love to hear it. Thank you.